Chapter 8.3, show that a quadrilateral is a parallelogram. Okay, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So first you need a quadrilateral. Okay, that's a four-sided figure. And if you can prove that both pairs of opposite sides are congruent, then that proves it's a parallelogram. All right, so right here, you need to prove both pairs of opposite sides congruent. All right, opposite sides. So these two and these two. If you can do that, that proves it's a parallelogram. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Once again, you need to start with a quadrilateral and then try to prove both pairs of opposite angles congruent. If you can do that, then you have a parallelogram. So you want to prove both pairs of opposite angles congruent. Okay, opposite angles in a quadrilateral are the ones diagonal from each other. So you have to check these two and also those two. Okay, it has to be both pairs. Example 1, an amusement park ride has a moving platform attached to 4 swinging arms. The platform swings back and forth until it goes over the top around a circular motion. AD and BC represent the arms. DC is parallel to the ground. Explain why AB is always parallel to the ground. Let's see. All right, so here's the amusement park ride, and let's look at the dimensions. Okay, this side and this side are both 16. All right, so those two sides are congruent, and the top and the bottom of the ride, those are both 38. So those are both congruent. So what we have here is opposite sides congruent. Okay, both pairs of opposite sides are congruent. And that proves that ABCD is a parallelogram. All right, ABCD is a parallelogram. Now, what is the definition of a parallelogram? For a parallelogram, opposite sides are parallel. All right, so I know that this side here is parallel to this side here. The top and the bottom are parallel. So we have AB parallel to DC. All right, so AB is parallel to DC. And that's by the definition of a parallelogram. All right, we proved it was a parallelogram by saying opposite sides were congruent. That proves it's a parallelogram, and now we know that opposite sides are parallel. And because DC is parallel to the ground, that means AB is also going to be parallel to the ground. Okay, they said the ground is line L, and it was given right here. DC is parallel to line L. Okay, DC is parallel to line L. And we said that AB is parallel to DC. So that means AB is also parallel to line L. So that's it. That proves it. All right, let's try guided practice number 1 and quadrilateral WXYZ. Angle W is 42, X is 138, Y is 42. Find the measure of angle Z. Is it a parallelogram? And explain. All right, so let's draw this first. All right, we have W, X, Y, Z. All right, W is 42 degrees. X is 138. Y is 42. And they want you to find angle Z. And they ask if it's a parallelogram. I'll give you a hint. The angles inside of a quadrilateral add up to 360. So see if you can find the missing angle and prove it's a parallelogram. All right, the angles inside of a parallelogram add up to 360. Well, we can't say it's a parallelogram yet. It's a quadrilateral. It has 4 sides. Remember, the total interior angles is n minus 2 times 180. Okay, n is the number of sides. So we basically just have 4 minus 2 times 180. And 2 times 180 equals 360. So the angles add up to 360 for a quadrilateral or a 4-sided figure. So we just subtract the other 3 from 360. All right, so we're right here. The measure of angle Z is going to equal 360 minus 42 plus 138 plus 42. All right, this is the measure of angle Z. So I'll do this on the calculator. Okay, on the calculator, I get 138. And that's in degrees. So that is the measure of angle Z. So right in here, I'll fill in the 138. And now they're asking, is it a parallelogram? Well, let's see. We have 4 angles. How about check opposite angles? We have 138 and 138. Remember, opposite angles for the quadrilateral, you go diagonal. Okay, and we have 42 and 42. All right, so what we have here, we have opposite angles congruent. Okay, once again, it has to be both pairs, not just one pair. Opposite angles are congruent. So is it a parallelogram? The answer is yes. Okay, because opposite angles are congruent. That proves it. Okay, if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So in this case, you only need one pair of opposite sides, but they have to be both congruent and parallel. All right, we are looking at opposite sides. The ones across from each other. We can see they are congruent. It's marked with the tick mark that indicates they are congruent. And we can see they're both parallel. This little red triangle here indicates that they are parallel. So BC and AD are both parallel and congruent. That proves it's a parallelogram. All right, so one pair of opposite sides are both parallel and congruent. That proves it. Okay, if the diagonals of a quadrilateral bisect each other, then it's a parallelogram. Okay, since it says diagonals plural, it has to be both diagonals. So let's take a look. All right, so we see the diagonals here in blue. This one is congruent to that one, and this one here is congruent to that one. We have this matches this, and that matches that. Okay, it has to be both diagonals bisecting each other, and that proves it's a parallelogram. Example 2, the doorway shown as part of a building in England. Over time, it has leaned sideways. Explain how you know that SV equals TU. All right, so we're trying to prove SV right here equals TU. So I would try to prove it's a parallelogram first. So let's see here. On the drawing, we have this and this are indicated as parallel. So that's ST and VU. Those are parallel. All right, so ST is parallel to VU. All right, in addition to that, we have the tick mark here, right here, and right here. So the bottom and the top are also the same length. So ST is congruent to VU. All right, ST is congruent to VU. All right, so we have parallel, we have congruent. So what we established here is one pair of opposite sides. They are both parallel and congruent. All right, this is the symbol for parallel. This is the symbol for congruent. One pair of opposite sides are parallel or congruent. So STUV is a parallelogram. Okay, STUV is a parallelogram. What is the definition or characteristics of parallelograms? Let's see. They are asking to prove SV equals to TU. But we know for a parallelogram that opposite sides are parallel and congruent. That's the definition of a parallelogram. So as a result, opposite sides here, all right, if you just go across opposite sides, we have SV and we have TU. So opposite sides, we have SV is congruent to TU. And that's because that is one of the characteristics of a parallelogram. So basically, prove it's a parallelogram, and that proves that opposite sides are congruent. Example 3, for what value of x is the quadrilateral a parallelogram? Okay, one thing to prove that it's a parallelogram is that the diagonals bisect each other. We already have the marks here. So we know that this and this are the same length. And now for the other set of diagonals, we want to prove that this equals that. All right, not prove it, we want to make them equal or congruent. Okay, so Fn has to equal ND. All right, Fn has to equal ND. All right, what we're doing here is that the diagonals bisect each other. All right. We want to make the diagonals bisect each other. So Fn equals Nd. Fn is 5x minus 8. Nd is 3x. And now it's easy solving for x. We want letters on one side, numbers on the other. Okay, you can go either way, but I want my x's over here. So I'm going to do minus 3x on both. 3x minus 3x cancels. The opposite of negative 8 is positive 8. So I do that to both sides. 8 minus 8 cancels. All right, you want the x's on one side and the numbers on the other. 5x minus 3x is 2x. Bring down the equal sign and we have positive 8. And dividing both sides by 2, x is just 4. They only ask for x. If you want to double check, plug in 4. 5 times 4 is 20. Minus 8 is 12. Plug in 4 here. 3 times 4 is also 12. So it matches. That's if you want to check. They only asked us to solve for x. All right, guided practice. What theorem can you use to show that the quadrilateral is a parallelogram? All right, so think about, we'll do them one at a time. Think about number 2 first. All right, let's see number 2. We have this 30 matches this 30, so the opposite sides are congruent. And we see right here, they are also marked parallel. So what we have is one pair of opposite sides congruent and parallel. All right, one pair of opposite sides are both congruent and parallel. All right, try number 3. If you look at opposite sides, the 5 and the 5 match, 7 and the 7 match. So what we have here for number 3, both pairs of opposite sides are congruent. That's for number 3. All right, check out number 4, please. We have the angles. Okay, if we want to check opposite angles, remember to go diagonal. Okay, the 115s match. And go diagonal again, the 65s match. So what we have here, opposite angles, congruent. Okay, I should say both pairs, because you need both pairs if you're going to do opposite angles. Both pairs of opposite angles are congruent. So that proves it's a parallelogram. All right, let's check out 5. What value of x is quadrilateral MNPQ a parallelogram? All right, this is for number 5. See if you can determine what value of x makes it a parallelogram. All right, so what you need to prove it is both diagonals bisect. All right, that's what you need. So we have this one already, okay? We can see the tick marks here. So this one matches this one, and we also need this one to match this one. All right, so they didn't give us a point in the middle, so I can't do the 2 letters for each segment, okay? But this here is 2x, and this one here is 10 minus 3x. I'm just going to set them equal. All right, 2x equals 10 minus 3x. I want the variables on the left. So the opposite of negative 3x is a positive 3x. All right, it cancels here. And of course, 2 plus 3 is 5. bring down your equals, bring down your 10, and solving for x, if you divide both sides by 5, okay, cancels right here, and of course 10 divided by 5 is just 2. If you want to double check, 2 times 2 is 4. Put a 2 in here. That's going to be 10 minus 6, which is also 4. So it checks out if you want to check, but they only asked for x. All right, so the summary so far, I'll post this on Google Classroom. Ways to prove it's a parallelogram. Both pairs of opposite sides parallel. Both pairs of opposite sides congruent. Both pairs of opposite angles congruent. One pair of opposite sides congruent and parallel. Or finally, show that the diagonals bisect each other. So those are the 5 ways to prove it. Example 4, show that ABCD is a parallelogram. Let's see. All right, so there's more than one way to do this. I think the easiest is to prove opposite sides parallel. Okay, so for the slope, I'm going to do the slope of each line. Okay, if you remember the formula for slope, it's change in y over change in x. Okay, so right here, I'm going to do the slope on each one. All right, so this line here, change in y, you have to subtract going the same way on both of them. Remember, it's y2 minus y1 over x2 minus x1. All right, you have to do it the same way. So I'm going to do, on this one, I'm going to do 2 minus 0. And then for the x, I'm going to do 5 minus 0. Okay, 2 minus 0 is 2. 5 minus 0 is 5. Now let's check this one here. I'm going to do 5 minus 3 for the change in y. And I'm going to do 2 minus negative 3 for the change in x. 5 minus 3 is 2. 2 negatives make it positive. 2 plus 3 is 5. All right, so I have 2/5 and 2/5. Those match. Let's check the other side. Change in y, I'm going to do 3 minus 0. Change in x, negative 3 minus 0. Okay, 3 minus 0 is 3. Negative 3 minus 0 is negative 3. And 3 divided by negative 3 is just negative 1. Okay, how about the other side? Change in y, I'm going to do 5 minus 2. Change in x, 2 minus 5. 5 minus 2 is 3. 2 minus 5 is negative 3. And 3 divided by negative 3 is negative 1. So opposite sides parallel and opposite sides parallel. That proves it. Both pairs opposite sides parallel. All right, both pairs of opposite sides are parallel. Now, the way they did it, they wanted to show that a pair of sides is congruent and parallel. So they had to use the distance formula and the slope formula for one pair of sides. So there's more than one way to do it. They did it with slope and distance combined. I did it with just slope on opposite sides.